Hello everyone. In this video, going to share about autoboxing and unboxing concepts related to wrapper classes in Java. Autoboxing and unboxing features were introduced in Java 5 to avoid the hectic process of converting primitives into objects and vice versa. Since Java 5, we don't need to manually perform this conversion. Autoboxing is the automatic conversion of primitive data type into its corresponding wrapper class. For example, char to character, int to integer, etc. Prior to Java 5, wrapper class methods like value of were predominantly used to convert the primitive into objects. Ever since Java 5, we can directly assign primitives into wrapper class object. Unboxing is the reverse process of autoboxing. Unboxing is the automatic conversion of an object of a wrapper class to its corresponding primitive type. For example, conversion of integer to int, character to char, etc. In the old Java 5 days, if you want to make a wrapper, unwrap it, use it, and then rewrap it, you might do something like this. Now, with the latest Java versions, you can simply code like this. It's simply a convenience. In the background, the compiler does the unboxing and the reassignment for us. Wrapper objects are supposed to be immutable, and this example appears to contradict that statement. Though it looks like Z's value changed from 10 to 11, actually, a second wrapper object was created and its value was set to 11. This can be proved if only we could access the first wrapper object. Custom wrapper classes. The built-in wrapper classes in Java are to wrap the primitive data types. We can also create a class which wraps data inside it. We can create our own wrapper classes in Java. Custom wrapper classes usage can be found mainly on certain structures like queues, stacks, etc. Let's look at some examples to understand in detail. Had created a class demo autoboxing and unboxing. Inside the main method, declare the primitive data type variables for int, float, double, and char. The same is applicable for other primitive data types byte, short, long, and boolean. First, autoboxing, that is, converting primitive into its corresponding objects. After the conversion, simply printing the new object values. Then unboxing, that is reverse of autoboxing process, converting objects into primitives. After the conversion, printing the primitive values. Let's execute and verify. The output is printed as expected. Earlier mentioned how we have to manually perform the conversion prior to Java 5. Let's look at that with the class demo manual conversion. In those days, you have to initialize integer wrapper object, unwrap it, that is, manually use int.value method to convert into primitive data type, then use the primitive value. Again, rewrap it by converting the primitive value into object to finally print it. With autoboxing and unboxing, all these conversions are taken care by the compiler itself and we get a simplified code like this. The output of both old and new ways is the same. Finally, for custom wrapper class, had created class my wrapper class, declaring private int variable, a default constructor, and a parameterized constructor. In the parameterized constructor, for the variable I, assigning the parameter value, encapsulating the field I with public getter and setter methods. Finally, overriding the toString to print as string. This is a simple illustration of wrapper class for int. The more meaningful ones would be like maximum or minimum members or something related to the real world problems. Now had created the class demo custom wrapper class. Inside the main method, first creating an object for my wrapper class with the default constructor and using setter and getter methods for initializing and printing the value. Then creating another object for my wrapper class with a parameterized constructor and simply printing the object. Here, the toString will be called and we will get the corresponding integer value while printing the output. In case the overridden toString method is not present, we will not get the integer value, rather the object reference. Let's execute and verify. The output is printed as expected. Thank you.